Jai Hind all of you. I am Dr. Rahul Bansal from Ajay Kumar Garg Engineering College, Ghaziabad. So this one is the next video lecture for the electron devices KEC 301. So let us start. In this video lecture, we will be discussing about the different transfer characteristics, that is gate characteristics and drain characteristics of Mosfet, right? In the previous video lecture, we had discussed about this introduction to the Mosfet, right? So in this video lecture, we will be discussing about the characteristics, right? So let us start. So if you draw the simple Mosfet circuit, so it will look like this one. So this is the Mosfet circuit. This one is gate, drain, source, right? Now, if you see this carefully, we have discussed in the previous video lecture that Mosfet is can be classified into two different categories, that is depletion type Mosfet and enhancement type Mosfet. Depletion type Mosfet consists of these aluminum plates, right? So, and depletion type Mosfet can work in both the modes, that is the enhancement mode and depletion mode, right? It means that we can apply the gate to source voltage positive as well as negative in case of depletion type Mosfet, right? So, and if I talk about enhancement type Mosfet, this can only work in this enhancement mode only. It means that we can apply only the positive VGS value. So if you see the characteristics, we had discussed in the previous lecture also. So if you see the characteristics of Mosfet, so it will look like, so whenever you apply the gate to source voltage, right, then the characteristics which is like drawn is called as the gate characteristics, right? So it will be like this one. So right, so when we increase the gate voltage, gate to source voltage, then correspondingly drain current will vary like this. Okay, so see, when you apply for the depletion type Mosfet, when you apply the gate to source voltage, right, then what will happen is, see, if you apply the gate to source voltage like this, right, this negative is connected to this gate terminal, and this positive is connected to the source terminal. Then what will happen is, this plate will have negative charges, that is the electrons, and correspondingly in the channel we will have the positive charges. Now these will combine with the electrons that were moving from the source to the drain. Then the drain current will reduce, right? So it will reduce like this exponentially, right? Now whenever gate to source voltage is 0, then the maximum current will pass through this, and it will be equal to IDSS, that is drain to source saturation current. Also it is called as drain to source safe current, right? So This point is IDSS, maximum drain current that is passed through the channel whenever gate to source voltage is 0. Now, whenever gate to source voltage is applied such that this negative terminal is connected to the gate terminal and positive terminal is connected to the source, then number of charge carriers will be reduced in the channel, right? So that the drain current will reduce correspondingly, right? So it will reduce like this, and a point will come when this channel will completely disappear, or you can say we will this charge carrier will not be there. At that point, this voltage is called as, this gate to source voltage is called as VGS off or VGS cutoff, right? Now this condition is called as depletion type MOSFET is working in the depletion mode when gate to source voltage is negative. Now, in the enhancement mode, as the depletion type MOSFET also work in the enhancement mode. So, in the enhancement mode, what we do is we provide the positive voltage, right? Like this. Suppose that this is the MOSFET that we were discussing, depletion type MOSFET, right? Here we have SiO2 layer and this one is now if you apply the positive gate to source voltage like this, now what will happen? Here we have positive charges, correspondingly it will have negative charges. Now the channel will have more number of electrons in this case. Due to this, the current, drain current will increase, right? So if you plot the gate characteristics, so it will look like this one. We will apply the positive VGS, that is, gate is connected to the positive terminal of the battery and source is connected to the negative terminal of the battery. In this case, the minimum value of the drain current is called as the drain to source saturation current, that is IDSS, right? And the drain current will be greater than this IDSS value for the positive value of VGS in this case. This type of MOSFET is called as the depletion type MOSFET, which is working in the enhancement mode, right? Next type of MOSFET is called as E-only MOSFET. Now, these aluminum plate, if you see carefully, these are very bulky and it requires the large area, right? Now, certain research experiments were performed and it was seen that we can replace this aluminum plate with the polysilicon crystal like this. Right? The advantage is that it will reduce the total area required and performance is also improved by using this polysilicon crystal. So we will connect the source, gate and drain, right? Now the difference between the depletion type MOSFET and the enhancement type MOSFET is that it doesn't have the diffuse channel. There is no pre-ejection channel in this case. E only MOSFET. E only MOSFET. There is no pre-ejection channel available. To create the channel, what we have to do is we have to apply the proper gate to source voltage so that channel can be induced, right? So whenever we apply the proper gate to source voltage, then we will have the channel. Otherwise, we will not have the channel. So whenever VGS equal to 0, ID will also be equal to 0. Why? Because there is no channel available. Now, whenever VGS is applied, right, then a channel will induced. Now, charge carriers can move from the source to drain, and correspondingly it will contribute towards the conductivity, and drain current this increases. Okay, and the drain characteristics will look like this one. Right, this VGS value, after which it will start conducting, it is called as a threshold voltage. Right, and it will increase like this. Drain current will increase like this with the VGS. Right, so this is called as the E only MOSFET gate characteristics. Right, so E only MOSFET work only in the enhancement mode only. It will not work in the depletion mode. Now, if I talk about the drain characteristics, right, so in the drain characteristics, what we have to do is we have to apply we have to keep this VGS constant, and we have to apply the VDS value, right? So here we have like plus minus VDS is like varying and VGS is kept constant. In this case, what will happen is, for the proper gate to source voltage is applied, a channel was introduced, right? So we are assuming that we are having the channel. So this is the channel actually, and charge carriers are moving from this place to this place, and drain current is flowing from this place to this place, right? Okay, now when VDS is connected, in this case, what will happen? when VDS is connected, then reverse biasing of this N plus with a P, it will increase, and it will cause this channel to be tapered like this. Effective channel width will reduce, right? So we will have this channel after introducing this VDS or increasing this VDS value. Now, if we further increase this VDS value, then this channel will be further reduced, right? This increase or decrease in the channel length due to changing of this VDS voltage is called as channel length modulation, right? So due to this channel length modulation, right, this effective channel length will reduce. So your characteristics will look like, okay, now a point will come when this channel will be reaching to this point, and at the same time electric field will be produced, and it will cause a constant current, which is the maximum current, drain current, to flow, right? So this point is called as VDS saturation point, right? After this, the transistor, that is Mosfet, will work in the saturation mode only, right? So this is ID and this one is VDS, right? So if you want to define the different region, so this region, when this ID, current ID is varying linearly with respect to VDS, this region is called as the triode region or linear region, right? After that, after VDS, right, this drain current is constant value. This region is called as the saturation region. So MOSFET will work as an amplifier in this saturation mode only, right? It will not work in the triode region, right? So we will have the different value of drain current for the triode as well as saturation region, right? So we will discuss this in the next video lecture. So thank you all of you. Thank you.